Hello everyone, my name is Karras. Today I will be presenting the paper entitled SparkReact, a novel and user-friendly graphical interface for the Apache Spark MLlib library. This is a joint work with my brother and colleague Aristeidis Karras, Mr. Agorakis Bompotas, Mr. Panagiotis Bouras, Dr. Leonidas Theodorakopoulos, and Professor Spyros Sioutas. Generally, visualization is a critical component across every software, as it enables users to familiarize with the environment and to perform certain tasks with ease that the program offers. The objective of this work here is to give an optimized graphical user interface for the Apache Spark MLlib library in order to apply machine learning algorithms quickly, conveniently, and effectively. So in particular, in this work we introduce SparkReact, which is a responsive graphical user interface that enables users to apply clustering, classification, and regression techniques with just a few mouse clicks by implementing and evaluating the certain algorithm and pre-building the code ready for import to Spark. In order to evaluate the usefulness of our tool, we perform crowdsourcing to two categories, on computer experts and on ordinary users. The results of this work indicate that both populations were satisfied with the tool at surprisingly 98%. And as per the time required to construct and evaluate a machine learning model took approximately 4 minutes using the GUI, the program that we created, namely SparkReact, while the ordinary methods took almost 4 times longer. A few words about the machine learning library for Apache Spark, which is also known as MLlib. The library includes several techniques for machine learning, such as clustering, classification, and regression. And moreover, it contains several packages for the use of linear algebra, statistics, and also machine learning pipelines. Here we have the Spark MLlib package and the main characteristics. It offers algorithmic optimization, model evaluation, model training, linear algebra, statistics, utilities, and others. Here we have a little graphical representation of the SparkReact main menu. So when the user executes the npm start command of the React.js component that we have built the program, it sees this menu. This is a cropped figure of localhost running the web server. So he can select among clustering, classification, regression, and to see about the project, the current version, and other things. When the user selects a menu, let's say clustering, he can choose among k-means and other available choices, and then as the user progresses through the pop-ups and the menus that come up, he can create, construct, evaluate, split the dataset, and do everything that a user does in the machine learning techniques with just a few mouse clicks. In order to create the program and to help users, the main purpose was to satisfy the users' complex demands, and in order to help them to make use of the MLlib library effortless and with ease. So as expected, it's essential for a user-friendly environment to be created in order to meet those needs. The first technology that we require is JavaScript, one of the most often used languages for online application development. And in particular, we use React.js, which incorporates JavaScript. So when the user selects an algorithm, the associated component is executed in the background. Throughout the application, we have 12 components which are responsible for the code up to the point of the execution. And additionally, we have other 19 components which are related to the algorithm's secondary operations. To evaluate the program and the usefulness, we have some participating members, and we basically send the program and some questionnaires about the program, and we ask certain things. And these members aid in collecting useful data for the evaluation of the software. There were 96 people equally distributed into two categories. We have computer experts in both applications and machine learning, and we have ordinary users with limited machine learning knowledge. Next, we have some usability metrics in order to evaluate the usability of our program. We have the effectiveness score, which is the percentage of tasks completed successfully, meaning that the entire amount of time required to execute each assignment. We have the efficiency rate, which is determined by dividing metric 1, the effectiveness score, by the amount of time it required to complete a given assignment. We have the error rate, which is any mistake committed while carrying out each task. And we have the metric 4, which help if the user asked for any assistance while completing each assignment. Here we have the two representations of the two populations. On the left-hand side, we have the computer experts. 89% of the computer experts find the tool as positive, that the tool aided and helped them to build a machine learning model in a positive way. 3.2% find it negative, that the tool is not good, or that it contains bugs, or it could be further improved. And 7.8% find it neutral, that they are okay with running ordinary code, or the program is just neutral. As per the ordinary users, we can see that 94% find it positive and a helpful tool, 2.4 find it negative, and 3.6 find it neutral. As you can see here, the impact of the tool is bigger than the other population. Moving on to the task that we ask the users to complete, we have 10 tasks. We have the description of each task, the difficulty of it, and the explanation. First of all, they shall execute the SparkReact, our program, the GUI. This is quite easy. It's just npm start command on the application that we create. Note that our application, when we sent the questionnaire and our application, we included documentation so as to help the users and to familiarize them with the program. So this was just to run the program. The task 2 was to explore the menus. Next, to select clustering, classification, and regression. Step 4 is quite crucial, because a details form comes up, which is basically, it asks for the version of Apache Spark that the user has installed on his or her computer. So this is quite important, because if it's filled in wrongly, the program would not run properly. Then we have the method selection from the new menu that's popped up after the fill-in form. Then we have the dataset import and the model training, as every ML technique. We have the dataset split, which is, it could be done on a predefined ratio or on a custom ratio, which is imported by the user. We have the model initialization and the code download, which code is downloaded in SBT file, which is the basically a zip version of a Scala code that is ready for import to Apache Spark. We have the model evaluation, and finally the model execution on Spark. Here we have the summarized usability testing for our program. We have the tasks. We have the 4 metrics that we previously discussed about. As you can see, for the first task to run the program, everyone was able to run the program 100%. It took on average 1 minute and 35 seconds. On task 2, all users were able to explore the menus. On task 3, all users were able to select a menu, a single menu. On task 4, we see that some users didn't quite understand what to fill in, or where to find the exact version that they have on their Apache Spark environment and on the Scala code that is installed on their computer. On the next task, which is the method selection from the new menu, all users did it right. And on tasks 6, 7, 8, 9, and 10, we can see that most of the users did it right, but still we have a portion of users that didn't quite understand, or they were not able to fulfill all the steps in order to complete the task. As per the time, it took on average 4 minutes to execute all tasks. The efficiency, as we said, is where we divide the effectiveness with the time, and we get the percentage of the efficiency. And as you can see, the efficiency, especially on task 1 to 5, was quite high. And as per the error, as the difficulty level of the tasks is increasing, the error rate is increasing too. So for example, the dataset import and the model training was the higher. And the help that the users required is also increasing as the difficulty level is increasing. Moreover, we compare the GUI, the tool that we created, which is SparkReact, as we already said, versus the ordinary machine learning library on Apache Spark. We have the first population, which is the computer experts, and we basically look on task 1 up to 9, which is the model creation, the dataset import, and so on, before they execute the model on Apache Spark. The effectiveness was 98%, so this is aggregated on all users from population 1. The time to create, construct, evaluate, and fulfill all tasks was 4 minutes. The efficiency is 23, and we also measure the same procedure where the users would have to construct a machine learning model from scratch. So they had to write code to split the dataset and do everything up to the last stage, which is to execute the code. And the effectiveness on computer experts was 90%. And what is surprisingly is that it took 14 minutes, while with just a few mouse clicks it took 4 minutes for the SparkReact. And next we have the second population, which is the ordinary users. Again, for task 1 up to 9, it was 94 percentage the effectiveness, and the time is a bit increased, 6.3 minutes. This is because these users didn't have a previous experience with machine learning and such techniques. And as you can see, this population find it quite hard to construct, evaluate, run, and so on, and machine learning by writing code, and it took on average 23 minutes. And the error rate also is quite high, and the help, the assistance they acquired. And lastly, we have the statistical descriptions of user experience. We have the human-computer interaction criterion based on the literature. We have the sum of users and the percentage. So 90 users out of 96 find it satisfying, 91 find it helpful, 85 rewarding, 92 friendly, 80 find it fun, 88 find it entertaining, 93 enjoyable, 91 that it supports creativity, 84 motivating, and 95 out of 96 find it safe to use. In the context of this work, a graphical user interface for the Apache Spark MLlib library is presented, namely SparkReact, as the one we discussed. The developed tool seems to interest both machine learning experts and ordinary users based on their answers, which are acquired from the questionnaire that we sent. And as per the time to construct, train, evaluate a machine learning model, it appears to be 4 times faster than writing code in Apache Spark. Future directions of this work include more algorithmic choices. At this time we covered 12 algorithms out of 24 included in the MLlib library of Apache Spark. And lastly, we aim to integrate more libraries within the software, not only MLlib library but others, including Karras and TensorFlow, in order to run distributed and with these deep learning frameworks. That was pretty much it. Thanks for your attention. If you have any questions, please let me know.